Hello and welcome to today's webinar, Ditch Your NAS, Move to Amazon EFS. My name is Daryl Osborne, and I'm a solutions architect with Amazon File Services. So in today's session, we're breaking this down into 4 phases. The first phase, we're going to assess your NAS workloads. We're going to review NAS and other storage platforms available with on-prem solutions. And then we'll take a look at the different workloads that you could be thinking about when you're moving over to Amazon EFS, specifically around some of those questions you want to ask yourself when identifying, is my workload a good fit for Amazon EFS? Phase 2, we'll talk about the different storage platforms available on AWS and where Amazon EFS fits in. We'll also look on phase 3 about how to migrate your workloads to the cloud, specifically around how do you ingest existing data into an Amazon EFS file system and what are the best practices to do that. In phase 4, we'll talk about how to test, optimize, and run an EFS file system. And we'll talk about some of the best practices that you should follow when doing so. And then at the end, we'll wrap up and summarize and have some Q&A. So with phase 1, let's assess your NAS workload. So first, what I'd like to do is really lay the foundation and talk about what a NAS is. So really a NAS, or network attached storage, is really a file level server or compute appliance that provides data access to a number of clients over a network to share file data. Typically, we see this using standard network file sharing protocols, such as Network File System, or NFS, Server Message Block, or SMB, or Common Internet File System, CIFS. We do even see out there in some areas the Apple Filing Protocol, or AFP, as well. So one thing I do want to emphasize that NAS is not DAS. So I'm sure you're all familiar with this, but I just wanted to make sure that everyone knows the difference between a NAS and a DAS. So a DAS, or direct attached storage, is really an extension or an enclosure directly attached to a compute appliance that has a additional storage associated with it. Typically, these are connected using a single connection, either a host bus adapter. There is no network or routing involved between this network or this connection between the server and this appliance. Some of the protocols involved or used with the DAS appliances are SCSI or SAS, eSATA, NVMe, and some are even fiber channel as well. So just wanted to emphasize that when we're talking NAS, we're really talking about a file system that is presented to multiple clients over a network. And it involves network protocols such as NFS, SMB, or CIFS. So I also want to emphasize that NAS is not a SAN, a storage area network. And I'm sure you're familiar with SANs as well, but just to make sure that we're all on the same page, that a SAN really provides block level storage to a number of clients. Typically, this is on a separate SAN network, fiber channel, and iSCSI probably being some of the most important or heavily used SAN protocols out there. And the SAN devices, or LUNs, are presented to clients, and they actually show up as disks, which is much different than how a server or a client sees a NAS, where it sees it more as a file server, while with the SAN, as I said, they show up as a disk. So I know there are some hybrid SAN NAS solutions out there. We're not going to be talking about those. We are specifically going to be talking about NAS, and that when a client or a server is accessing a NAS appliance, they are looking at this as a file server or a file system. So typical NAS workloads could be, one of six that I've listed here, and I'm sure there are many others out there as well. But typically, when I think of NAS, I think of serving up home directories or web serving data that is shared among multiple web servers within a web farm. Even line of business applications, ERP applications, applications like that need to share data would typically use a NAS. Content management, development environments as well, CI/CD or even Visual Studio as an example, would leverage NAS storage, as well as backup and disaster recovery solutions would also do this. So when we're talking about identifying the different workloads and where that would fit in terms of how that maps to cloud storage offerings that we have, there are a number of questions I like to ask customers to identify if this is a good solution or not. So what I want to do right now is quickly go through some of those questions. And if you could just write these down or make a mental note of what the answers are, I think it's going to help you identify if this workload is a good fit for Amazon EFS or not. So the first question I like to ask is, what is the OS platform that the application needs? Is it Linux or is it Windows? Next, if it is a Linux application, what is the distribution and kernel version? So are you running Amazon Linux, and what is the kernel version? Maybe it's Debian 8 or 9, maybe it's RHEL 6 or 7, CentOS. What is the Linux distribution and the kernel version? These are two important attributes that you should identify when making this assessment. Next, what is the shared file system protocol that you're running today on the server side? So are you running NFS v3, NFS v4? Is it an SMB file server? So is it SMB2, SMB3? Then also on the client side, so if you are running a network shared file system on the client side, what client protocols are you using? Is it NFS v3, NFS v4.0, 4.1, SMB? Again, identify what those client protocols that you need to in order to access your network shared file system. Another question I like to ask is around compliance. Are there any internal or external compliance requirements? If they are external, what are they? Is it FedRAMP? Is it PCI? Identify those external requirements, and that will help us determine which storage platform is best suited for your workload. I also like to ask information and ask about encryption. So do you require encryption to satisfy any of these other compliance requirements? So do you need encryption of data at rest? Do you need encryption of data in transit, or do you need both or none? Very important. Now let's talk about some of the performance and capacity attributes. So what is the storage capacity requirements today? Are you looking at something very small, maybe 100 gigabytes, or just something very large? Maybe you need a terabyte or 500 terabytes. What is the daily growth of your data in terms of adding data to the file system? Is it 100 gigabytes a day? Is it a terabyte a day? Information like that is important. What is the use case? We're showing 6 use cases here. Is it one of these, or is it another use case? Identifying that is important. And maybe you'll have multiple use cases accessing this same NAS environment. So it is good to map this out, use case, to a NAS, because within AWS, because we're talking about these virtual services or these fully managed services, you can have a service or a file system for one workload and a completely different file system for another workload, as long as they don't have to interact and exchange data. You don't have to think of it as you're putting all of this capital expenditure into an appliance and you want to get the most out of it. So you're going to have all these different applications and workloads trying to access this one appliance. We don't have to have that same mindset in the cloud. You can break it down and you can have logical separation with file systems, because again, you don't pay for this huge appliance. You only pay for the amount of data that you're storing, regardless of the number of file systems that you have created. So very important. Another question is around your application and version. So identify the application version number, and what we can do is see if we've already worked with some of these application developers, and maybe they've already tested their application and that version with EFS. And maybe there are some best practices for that application to best use EFS. So again, identify those and write those down. Is your application multi-threaded? This is important because Amazon EFS is a highly parallel distributed file system. You can best leverage this design by using multiple threads. So is there the ability to multi-thread your application? That's important. How many clients are going to be accessing the file system? Is it 1 or is it 1,000? What are the I/O utilization requirements in terms of what is the percent read or percent write? In terms of the size of the file system, how many files is there? What's the average file size per directory? What is the directory depth? How many subdirectories do you have? And if you could even share a sample tree, directory tree, that's also important. When it comes to the average size of the files, what is the minimum size? What's the smallest? What's the largest? What's the average? That's important as well. The average I/O size, so depending on how your application accesses the file system, it could have a different I/O size that it's pulling. What is that? That could be very useful. And then in terms of throughput expectations, what are you achieving today? And what do you want to achieve when you go to the cloud? Do you just want to sort of lift and shift your application over? Or are you having performance pain today that you want to alleviate and overcome by moving to the cloud so that you need a higher throughput for your application? So again, these are important questions you should be asking yourself. Also along that same line of performance, your IOPS expectation. How many IOPS are you achieving today with your file system, and what do you want to expect in the future? And also latency. So what is the latency expectation? What are you experiencing today, and what can your application live within in terms of latency? So now that we've sort of gotten around phase one, we've talked about some of the workloads, some of the questions you should be asking yourself when identifying the workload that you want to move over. Let's talk about choosing the right cloud storage platform. So when you think about choosing a cloud storage platform, typically you think around these three main things. First, the storage type. So we have file, block, and object storage platforms available within the cloud, which is best suited for your application. When we talk about features and performance, we want to identify again, what are those features and performance requirements that you have? And then next, we want to talk about economics. Definitely total cost of ownership is important, and we want to see which sort of fits within your budget. And how is that going to change over time as your file system will continue to expand and grow? So let's talk about all three of these, file, block, and object storage, and let's define them and see where they fit in terms of our NAS migration over to the cloud and how you want to ditch your NAS. So first is object. So object, this is really where data is stored in a container. This container is called an object, and it's really identified by a unique key. And it's stored within a flat hierarchy. So there is no hierarchical structure. It's basically a flat space. Typically, you access the objects over using a simple API. So you issue, get or put requests. and the API is commonly accessed over the internet. So object definitely is not a NAS. So if you have a NAS now and you have workloads leveraging a NAS, object is not the right storage platform for you. Now, I know there are some front ends or some layering that you can do to put some type of abstraction in front of an object store to present a file system access to it. But just keep in mind that object is not designed to be a NAS. There are a number of things that it does not have in terms of POSIX, file system locking. When you're trying to have multiple clients accessing the same object, it's a completely different experience. So we just want to make that distinction. So now let's talk about blocks. So block store is really when you have a disk or a set of disks. Usually it's attached to a single computer and data is stored in chunks. And it's called blocks basically on this disk. Operating systems will work with block storage by presenting its data in a file system format. And it presents this to users if they're logged in, or to applications that are running on the server. Now, the underlying raw data is actually being stored in these blocks, but it's being accessed over a file system. So when you think about block storage, you're probably thinking about locally attached disks. So again, block storage is not a NAS. Now, can you put a file system on top of a block device to present a NAS? Absolutely. But in terms of just block storage and NAS, there's definitely something else you need to do to block storage in order to present it as a network shared file system over a network. So file storage. So file storage is data stored natively as files in a hierarchical directory structure. So this is important. This is something unique than block and object that we already talked about. So each file and directory has particular metadata associated with it. Things like owner, permissions, create time, things like that are associated with the metadata. Now, in terms of really the enterprise context, so file systems that store this data accessed over the network can be accessed by multiple clients at the same time. And this is one of the advantages of a file system in the cloud, is that you can now have multiple clients accessing the file system. So with that definition of file storage in the cloud, where does it fit in terms of a NAS? So definitely, file storage is a NAS. There are, a lot of similarities between, file storage and a NAS, and we can definitely see some of the benefits when we look at why file storage is so popular. So, for one, it works natively with the operating systems. So operating systems are designed around file storage. File systems are the abstraction used to display the data to these end users. And file systems use file APIs to allow applications and users to read and write data. So it also provides shared access to the data while providing consistency guarantees and locking functionality. So this is very unique to the file system. So these characteristics are very important when you have multiple clients sharing this data and accessing the same data set at the same time. And lastly, it provides a hierarchical namespace. So this is really how we think naturally of how data is organized. So to have this hierarchical structure really helps us identify where the data fits within the structure. So how do these three storage platforms compare in terms of throughput and latency? So here on the x-axis, we have latency, and in the y, we've got throughput. So block stores generally provide the lowest latency, but they really don't scale to the amounts of throughput achievable by file systems and object stores. So typically, these workloads would require really low latency and relatively low amounts of throughput. This could be maybe for database applications or boot volumes. And we typically see this only accessible from a single server at a time. So as we move from left to right, we look at file storage. Now, generally it's lower latency than object store, higher than block, but again, we have high levels of throughput capable to these file systems. So you're able to, achieve, tens of gigabits per second throughput to some of these file systems. And then finally, object on the far right. So this is where you're able to achieve the highest levels of throughput and scalability. But again, it's really not designed for latency sensitive applications. So when you look at this, you really see that a file system sort of it's a nice sweet spot right in the middle where we have lower latency than object, but we have higher throughput capable of block, and we have the added benefit of being able to be accessed from multiple clients concurrently. So before Amazon EFS was launched, it was launched just a little over 2 years ago. How did customers run these file systems in the cloud? So typically you would need to have basically build it yourself and a do-it-yourself solution. So you have clients running within a VPC, maybe it's running within a single AZ. You would then spin up an EC2 instance. You would manage the operating system on that instance. You would put on a file system, a shared file system on that instance. You would mount multiple EBS volumes that would be served up, and you would export those. And that's how your clients would be able to access this. Now, in order to achieve redundancy and high availability, you would typically need to spin up another EC2 instance in another AZ. Again, mount multiple EBS volumes to that instance, and then have some type of synchronous replication. You would have to set this up yourself in order to have that data synchronized to and written to this other AZ to have more availability and more durability. Then you could also have other clients from other AZs accessing this environment. So it truly was a do-it-yourself solution, and you would have to manage the operating system level, you would have to manage the hardware, the file system level, and the replication level. So there's a lot of moving parts there that you would need to manage yourself. So luckily, Amazon EFS came along, and Amazon EFS is a fully managed service that makes it easy to set up and scale file storage in the Amazon cloud. So really with a few clicks of the management console or a few API calls, you're able to stand up and create an EFS file system within really a matter of seconds, and be able to mount that file system within maybe a minute and a half. And these file systems, with these file systems, you gain the feature set of that NAS that we talked about in terms of some of those differentiating attributes, like full file system access semantics that you need, strong consistency, and file locking. So you get that all within Amazon EFS. So let me ask this question up front, and we'll come back to it. So is Amazon EFS a NAS? So ask yourself that, and we'll come back to this at later on in the webinar. So some of the key feature designs that we built into EFS when we designed it, these are some of the core tenets, is that we wanted to make sure that it was simple. So there is no hardware, networking, or file layer to manage. As I mentioned, just a few clicks or a couple of API calls, you have a petabyte scale elastic file system ready to use right away. And again, because you only pay for the amount of data you're storing in the file system, you have this environment set up, but you're not paying for it yet. And you only pay for it once you start adding data to it. So it's a great way to get up and running really, really quickly. Another simple aspect of EFS is the pricing model. Again, very simple pricing model, and we'll talk about that a little later. The next core tenet we used when we built EFS is elastic. So the file system automatically grows and shrinks as you add and remove files. So there's no need to provision storage capacity or performance. You only pay for the amount of storage space that you use, and there's no minimum fees. So it elastically expands and contracts based on the amount of data you're adding and deleting from your file system. The third core tenet is scalability. So EFS file systems can grow to petabytes of capacity, and the throughput of the file system scales automatically as the file system grows. So it also provides consistent low latency regardless of the size of the file system. Now, I know if you've run some file systems in the past and you continue to add more and more data and you have more and more clients accessing this file system, typically you're going to get to a point where it's just going to be overloaded. Well, with Amazon EFS, we continue to scale out, and we can scale to an unconstrained number of storage servers within our environment. So it allows customers and file systems to continue to grow and get consistent low-level access, latency access to the file system, regardless of the size and regardless of how many clients are accessing the file system. You can really scale this from one user or one client all the way up to thousands and thousands of clients accessing the same file system without a penalty involved. Now, these three core tenets are all based on a foundation of high availability and high durability. We wanted to make sure that the file system is available to you when you need it, and the file data that you're storing in the file system is always accessible. So let's talk about the performance of EFS. So there are two performance modes offered. Now, the default performance mode is general purpose, and it's recommended for the majority of workloads out there. The other performance mode is max IO, and that's really recommended for scale out workloads. So if you have a workload that needs, in hundreds or thousands of instances accessing this file at the exact same time, then you may consider max IO, but we do recommend starting out with general purpose during your test to see how your application actually behaves. So the next performance mode we're going to talk, or the next attribute of file systems is the throughput mode. So again, we have two different throughput modes that we offer. The first throughput mode is bursting throughput mode. That is recommended for, again, the majority of our workloads. And that is when the throughput of your file system grows as the data in your file system grows. So the more data you put in the file system, the more throughput you're able to achieve. And within this, we built in a bursting model because we understand network shared file systems are bursty in nature. So for short periods of time, you'll need a lot of throughput. And for the rest of the time, you need low or average levels of throughput. So we built that automatically in that. So that's built in as a part of the performance model and a part of the pricing model as well. So the other throughput mode is what we call provision throughput mode. And this is recommended for workloads that require a higher throughput to storage ratio than what is offered in bursting throughput mode. So in this mode, basically what you're doing is you're provisioning a set amount of throughput regardless or independent of the amount of data being stored in your file system. So this could be useful when you're ingesting a lot of data into your file system, when you need high levels of throughput, but your file system is still very small. Or it could be you have a workload that is throughput sensitive. So basically meaning that the amount of data that you have is relatively small, but you need high levels of throughput. And the storage to throughput ratio that you require isn't satisfied with the bursting throughput mode. So you would want to use the provision throughput mode. So again, we recommend starting out with bursting throughput mode to see how it works. But with throughput mode, you can actually change the throughput mode and change from bursting to provision when you need to. Then you can also increase and decrease your provision throughput when you need to as well. So very, very important attributes of a file system. So now let's talk about some of the security models and compliance of an EFS file system. So when you want to control the network traffic to your file system, you can use the standard Amazon VPC security group and network ACLs. So if you're familiar with them, great, you're going to fit right at home with Amazon EFS. You can assign up to 5 VPC security groups to an endpoint to an EFS file system. We call that a mount target. We'll get into that a little later. So you can associate 5 different security groups with that mount target. So you can grant different clients either other security groups, IP addresses, or CIDR blocks. You can grant them access to this file system. In terms of file control and directory access, we are POSIX compliant. So again, you would issue your standard POSIX permission calls to control what user or group has access to different files and directories. When it comes to controlling API access, you would use the AWS Identity and Access Management service, so IAM, and you can control action level and resource level permissions. When it comes to encryption of data, so we do offer encryption of data at rest and in transit. At rest, you would set up at the file system when you create it, and in transit, you would set up when you mount the file system on from a client. So those are separate. You can have both running at the same time, or you can either have one or the other. Now, when it comes to compliance, so Amazon EFS is HIPAA eligible. We do offer BAAs, and you can run a PCI DSS compliant application on Amazon EFS. So we are available in 10 regions today. And again, we plan on expanding this to more regions in the near future. So stay tuned. If we're not in the region that you need, stay tuned and we will be there shortly. Let's talk a little bit about some of the economics of EFS. So as I mentioned, there are no minimum commitments or upfront fees. Since it's a fully managed service, there's no hardware to manage, and there's no need to provision storage. It automatically grows and shrinks as you add and remove data. So there's no additional fees or charges or billing dimensions associated with that. So there are also no request charges. So this is a little different than some of the other storage platforms that we offer. There are no request charges associated with Amazon EFS. It's really a simple pricing model. So there's a pricing model with the bursting throughput mode, where it's just based on the amount of data that you're storing. And then there's a pricing model, really 2 dimensions, when you're running in provision throughput mode. There's, again, the storage dimension, and there's also a throughput dimension based on the amount of throughput that you provision for your file system. So again, if we go back to this slide, we look at how customers used to run a file system, a shared file system, before EFS. So when we take a look at some of the storage costs associated in the costs associated with this entire solution, we see that there's EC2 instance storage costs, there's EBS volume costs, and there's inter-AZ data transfer costs associated with this. So when you really look at that and compare it to Amazon EFS, we typically see around a 70% savings when running an EFS file system than if you were running it yourself on EC2 and EBS. And these are not the soft costs associated with it. So we're not talking about some of the labor involved and some of the other costs. This is just looking at the resources being used and leveraged within AWS. So EFS is designed for a wide spectrum of use cases. So some of the use cases that I mentioned earlier, definitely they would fall here within EFS. It really falls and goes from the highly parallelized workloads and scale out jobs in the analytics and media and entertainment areas, all the way to metadata intensive jobs where it could be home directories or dev tooling. So there is a wide spread of use cases and customers running solutions on EFS. So if we take a look at this, don't take my word for how great EFS is in terms of the wide spectrum of applications that are being run on it today. These are just some of the customers that are using EFS. Some of them are using it for database backups. So JD Power and Cisco are using it for backups, where they're actually storing data that's stored on EBS volumes and within a database over to EFS because they have immediate high throughput access to that backup. We also have customers running M&E workloads. So it's very popular for transcoding workloads. Zynga and other applications and other vendors are using it for those types of use cases. We have web serving and content management use cases on EFS, as well as big data and analytics. So again, lots of customers using EFS today, using them, a lot of different use cases and workloads are leveraging EFS. So with that said, let's go back to that initial question that I asked earlier in this section. Is Amazon EFS a NAS? So definitely we can say yes, it is, because we support some of the same protocols, NFS v4, which includes 4.0 and 4.1. So definitely we are a NAS in that sense, but we're actually more than just a NAS because we have the high availability and high durability that you just can't get when you're trying to run NAS yourself or do a do-it-yourself solution when you're running it on, say, EC2 or EBS, or even a software appliance that's running within the same AZ. So in phase 3, what I wanted to do is spend a little time and talk about migrating workloads to the cloud. So if we go back to the typical 6 workloads that we identified earlier, we see that there is a need to move these from an on-prem solution over to the cloud. You will have applications, and you typically move applications one at a time. So having the ability to set up a NAS for a shared network file system in the cloud is useful when you're moving individual workloads at a time. Don't think that you need to lift and shift an entire NAS over. And because it is elastic and scalable, you can start out small and move one application or one workload at a time. And then you can just continue to add to that existing file system or add a different file system based on the specific requirements of that file system. Again, all of your file systems don't have to be running the same performance mode. They don't all have to be running the same throughput mode. So you can customize it and have one file system customized for one use case and one workload, while you have another file system customized for another workload. So we really see all of those different workloads fitting in within the typical EFS workloads, anywhere from some of the scale out jobs and large data analytic jobs, all the way down to container storage or even home directories or dev tooling applications where you need low latency, single threaded access to the file system. So when you are ingesting or moving this data from on-prem to the cloud, what do you think about? So typically you think about, well, how do I connect? And how do I move this data over to the cloud as fast and as easily as possible? So we do have a tool called the EFS File Sync. And what it is it's an AWS management console tool that allows you to ingest data from an NFS source to an EFS file system securely, easily, and very fast. So it is very simple. As I mentioned, it's a management console tool. You go to the console, you set up an agent, you set up a task, then you run that task and that's it. It's a very simple process. It's very fast. We've measured up to 5 times faster than if you were trying to use standard Linux copy commands. And it's secure, so the data is actually encrypted as it's being transferred. So there's no need to set up a VPN connection or to have a direct connect. You can ingest data into an EFS file system using EFS File Sync without setting up some of these other mechanisms. So if for some reason you don't want to leverage Amazon or EFS File Sync, there are other tools that you can use that are open source that can allow you to ingest data into an EFS file system very quickly. So here are some that I've identified, some that I've tested, and I just want to walk through them very quickly, some of the benefits and sort of the pros and cons of each one. So many of you, if I asked you to identify a tool that you would use to copy data from one file system to another, you would probably say, yes, I use rsync. So that is probably one of the most common answers that I get. So rsync, there are a couple of attributes with rsync that really don't align with the benefits of EFS. One, rsync is single-threaded. And because EFS is a massive parallel file system, it's really best to access EFS using multiple threads. Also, rsync is chatty. Now, I know there are some options you can turn on and off to make it less chatty, but overall, it's a more chatty tool than just say that the standard Linux CP command. So with that, because there is higher latency per file system operation using EFS than if you were using, say, an EBS or a locally attached disk, you want to reduce the number of network calls, and you don't want to have a chatty network application. So again, those two attributes really don't align well with EFS, so we don't recommend using rsync with EFS. A standard CP is a little better than rsync, but again, it's still single-threaded, so not the best solution, but because it is less chatty than rsync, you can achieve a little higher throughput when you're using just the standard Linux CP command. One option is FP Sync. So some of you may be familiar with the open source tool called FPart. FP Sync is a utility that's a part of FPart, and it is a multi-threaded rsync. So it's a great addition to FPart, and now you're able to issue those same rsync commands using FP Sync, but again, it's going to be multi-threaded. So it is better than a single-threaded rsync, but there are other tools available that can even have an improved throughput to EFS. Just the standard Linux CP and running new parallel. Those two together actually offer quite a bit better performance than just the FP Sync. Again, a less chatty tool, and now you're able to manage the threads yourself using new parallel. You're able to achieve high levels of throughput. But really the best throughput that I've been able to get when ingesting data into EFS using open source tools is a combination of FPart, CPIO, and new parallel. So FPart has a mechanism to basically create what we call a partition file. And a partition file is just an index of all of the files and directories within a source. And the other part is CPIO. Now, many of you may be familiar with CPIO. CPIO is typically used for archiving, but you may know that there are 3 modes to CPIO. There's copy in, copy out, and copy pass. So what we want to do, we want to leverage copy pass. So with copy pass, it actually, you have the ability to give it a partition file. That partition file identifies the files and directories within the source. And with new parallel, we're able to split that up across multiple threads and then do a CPIO copy pass into an EFS file system, and we can achieve high levels of throughput. So in this example, I ran it a little earlier on a C5 large instance, and as you can see here with rsync, we were getting around 12 megabytes a second. Again, single-threaded, very chatty. The CP was a little better. We're getting 16, around 15 and a half, 16 megabytes per second. But as we went to a multi-threaded solution like FP Sync or CP and new parallel, you can definitely see the benefits of using a multi-threaded solution. And then all the way to the end, with FPART, CPIO, and new parallel, we're able to get substantially more throughput. So again, this is the exact same source and destination. All we're changing here is the tool. And this is going from a local EBS volume attached to that instance over to an EFS file system that's mounted to it. And the only thing that changed to give you these results is the tool that we're using. So again, some of the best practice is identified here. Use a multi-threaded tool and use a less chatty tool. We do recommend FPART, CPIO, and new parallel, or at least a multi-threaded tool to help leverage this distributed data storage design of Amazon EFS. So now let's talk about, testing, optimizing, and running an EFS file system. So typically, let's go back to this. So typically, we want to look at the solution, the architecture around the solution when we're going to be testing and optimizing. What is the use case? What is the application? Is it going to fit? Next, we want to take a look at the functionality. Can we test the functionality of your application accessing an EFS file system? Does it support NFS v4, including 4.0 and 4.1? What Linux kernel are you using? All of these play an important factor in testing the functionality of your application accessing an EFS file system. And then performance and optimization. Is there anything from the client side that we can do to better the performance accessing EFS? And then on the EFS side, is there anything we can do in terms of selecting the right performance mode or selecting the right throughput mode for our application to get the best performance out of EFS? So if we take a look at the architecture of EFS, when you create an EFS file system, you create it within a region. You don't create it within a VPC. It's a regional construct. So once you create a file system, it's there. Problem is, you can't get access to it right now. There's no way to access it. So how do you access an EFS file system? So typically what we do is you create a VPC. Within that VPC, it's typically spread across multiple availability zones within that region. You have your NFS clients sitting in these availability zones. And then you create what we call mount targets. And mount targets are endpoints of an EFS file system. They show up in your VPC as an ENI, an elastic network interface. So these ENIs are like any other ENIs in your VPC. So you can control access to those using standard VPC security groups. So you would then grant access to the file system through using these security groups to the NFS clients that you want accessing this file system. You could do this all using a DNS name or a file system ID, and you would issue a standard NFS mount command in order to mount that file system. So in this environment, there are no single points of failure. So it is engineered for high availability and high durability. So the DNS name or file system ID, the mount targets, the file system itself, there are no single points of failure. So again, this sits on this foundation of high availability and high durability. Well, how do we go about testing EFS? So let's go ahead and actually create a file system. I'll just show you exactly how simple and easy it is. It's really as simple and easy as 1, 2, 3, creating a file system, creating mount targets, and mounting that file system. So let's go ahead and jump over to my AWS Management Console. And here I'm in the EFS file system, the EFS console. And if I just go ahead and click on Create File System, I would want to identify the file system where my mount targets are going to be created in. So by default, my default VPC is going to be selected. I want a mount target in all three AZs within my that are a part of my VPC. So I'm going to leave all this with the default entries, automatic IP addresses, and I'm just going to use the default security group. Now I could remove this, or I could add in additional security groups based on my needs. Now I can actually add a tag, so I can name this file system. I would then choose the performance mode. Do I want to run this file system as a general purpose file system or a max IO file system? Again, best practice, start with a general purpose mode file system and test your applications. If you need to go to a max IO file system, you will need to create a new file system and then copy that data over. But again, we do recommend that you test your file system and your application and workload first using a general purpose mode file system. Then you also choose the throughput mode. So do I want to run in bursting throughput mode or provision? Again, the default is bursting, and I'm going to go ahead and use that. Enable encryption of data at rest. So I can go ahead and check that box, or I can leave it unchecked. So if I checked it, I could actually select the CMK, or the customer managed key, to use to encrypt my file system. But in my case, I don't need it, so I'm not going to check it. Now the next step, I'm just going to review my file system. This is what's going to be created, and then I click on Create File System. And really it is that easy. What I've done is I've created the file system. I've created, or in the process of creating, mount targets, one in each availability zone. And within roughly a minute and a half, maybe 2 minutes, you're going to be able to have access to those mount targets using the DNS name. So there is a single DNS name that's created for your file system, and that DNS name can be used to mount the file system from all of your clients within that VPC. So let's go back to the presentation, and we'll talk about what you actually, the API calls that are available to manage a file system. So as you already saw, there are some API calls to create a file system and to create and manage mount targets. Those were executed on my behalf as a part of the wizard that I used within the management console. There are also API calls to tag a file system, to manage the file system after the fact. So if I wanted to change the throughput mode of a file system, I could go ahead and do that. Also view some of the details of the file system and delete the file system or delete mount targets. So all of these are the standard API calls that you would that are available for an EFS file system. Very simple, very easy. Again, we wanted to abstract all of the heavy lifting involved in running a network shared file system that is scalable and can scale up to petabytes of size. We wanted to eliminate all that hard work and make it as simple and easy as possible. So in terms of functional testing, it is POSIX compliant, and it compliant with NFS 4.0 and 4.1. So if your application requires this today or uses NFS v4 today, then it should just work. But again, we always recommend that you test your application to make sure that it works well with Amazon EFS. So there are mount options, as with any NFS mount. There are some mount options that you can use to mount the file system. So what we did, we actually built an EFS mount helper. This EFS mount helper is an NFS wrapper that will actually wrap all of the best practices and mount options that we recommend to issue the mount command to mount your file system using NFS protocol 4.1. So this is an open source tool that you can download from our GitHub repo, or if you're running Amazon Linux, it's a part of the repositories. You can just do a simple yum install Amazon-EFS-utils, and you can install the EFS mount helper on your Amazon Linux machine. So again, you can take a look at the actually mount command differences between the standard NFS mount and the simplified EFS mount using the EFS mount helper. Really, the only thing you need to supply with the EFS mount helper is identify that you are using the EFS mount helper with the -T EFS. If you want to have an encrypted connection, basically enable encryption of data in transit, you would use the option TLS to mount that file system. You'd have the file system ID and then the mount point that you want to mount the file system as on that instance, and that's it. All the other best practices and recommended mount options that we have are automatically included when you're using the EFS mount helper. So when you're up and running with an EFS file system, what is there to do? Well, not much. That's one of the benefits of running a managed service within AWS. You could monitor and look at, review the CloudTrail logs where all of the API calls are being logged. These are API calls to manage the file system, so creating file systems, creating and managing mount targets, deleting file systems. These type of API calls are going to be recorded and available in CloudTrail. Amazon CloudWatch will give you performance metrics on how your application is leveraging and how hard it's driving the EFS file system. So you can go ahead and monitor the performance of the EFS using CloudWatch. Also, you can perform backups. So we do have an EFS to EFS backup solution that you can use. So in terms of CloudTrail, all of the API calls that you issue either through the management console, the SDKs, or the CLI are logged and recorded in CloudTrail, and that's going to be available in the S3 bucket that's associated with CloudTrail. These are the 8 CloudWatch metrics available to each file system. We're able to see how your application is driving the file system. So we recommend that you monitor those as well. I did write a CloudFormation template that creates a CloudWatch dashboard for an EFS file system. This CloudFormation template is available in my GitHub repository for EFS. It's actually an EFS tutorial that I wrote. It's in the monitoring section, and it's a simple CloudFormation template you can click on through the repo, or you can download and review yourself, where it will create this dashboard so you can look at how your application is driving the file system in terms of throughput, megabytes per second, IOPS, as well as what's the IOPS utilization, what's the average IO size. Information like this is calculated using metric math, which is a feature of CloudWatch. So in real time, you're able to see in familiar metrics and units like megabytes per second. You can actually see that real time within this dashboard. So I encourage you to go out to the repo, take a look, download that. Customize it if you want to, but it's a great resource for you to start monitoring your EFS file system. As I mentioned, we do have an EFS to EFS backup solution where you can set up an automatic reoccurring backup of your file system from one file system to another. And this uses CloudWatch scheduled events to go ahead and kick this off, say on a daily basis, where we will spin up the environment for you and back up that file system on a regular occurring basis. So again, this is a solution that we have built. It is available from the resources page within Amazon EFS, or if you just do a simple search for EFS to EFS backup solution, you'll be able to find a link and access the user guide as well. So when we're wrapping up, let's just go ahead and review some of the best practices when we're using an EFS file system. So again, test with a general purpose mode, performance mode file system. We do recommend that. When you start, we start with a bursting throughput mode. Your file system running in bursting throughput mode. Use Linux kernel 4 and above. There are some performance benefits in using the latest Linux kernels out there. There are some performance hits when you're using some older kernels in terms of performance and parallelization. So we do recommend Linux kernel 4 and above. Use the EFS mount helper because it will mount using our recommended mount option, and it will mount using the NFS 4.1 protocol. Try to aggregate your I/O. Use a larger I/O size if you can with your application. Use multiple threads. Again, it goes back to some of the questions that I asked earlier in the session. And these are, some of the answers that you give to those questions will really help determine if EFS is a good fit or not. So we do want you to use multiple threads if your application supports it. Multiple instances. Can you scale out? Again, we want to leverage the cloud. Instead of having a lot of resources running on a larger instance, spread that workload across multiple smaller instances. You sort of decrease the blast radius if that instance were to fail, and then you can take advantage of the distributed data storage design of EFS and have multiple threads accessing the file system. Use multiple directories. Again, when you're, don't try to put, millions and tens of hundreds of millions of files into a single directory. Spread that out across multiple directories, and you'll be able to avoid inode contention, which is common among just Linux file systems when you're trying to access, have multiple threads accessing a single inode. You could experience inode contention. So we do recommend you building your application and designing your application so you can leverage multiple subdirectories. And then monitor your file system using the dashboard that I mentioned, or just taking a look at it in CloudWatch. So there are a number of resources available to you. It's out on our EFS page. There are blogs, we've got white papers, reference architectures, a lot of different tutorials and our documentation. So I recommend and encourage you to go out there to take a look at that. Also, the tutorial that I wrote is available on GitHub. So go out there, give me some feedback. There's a performance tutorial that you can go through. There's a tutorial on creating a file system, and then there's a monitoring tutorial as well. So you can do, all three, or you can, pick and select which one you want to do, and it will give you step-by-step instructions on, either how to create a file system, how to get the best performance out of the file system, or how to monitor your file system. So again, my name is Daryl Osborne. I want to thank everyone for your time today, and now we'll have a little time for Q&A.